project. And yeah, just commenting some code. Just trying to make sure I got everything configured here. So it looks like we're live. Let's check out Twitch. Sweet. Okay. So I guess the first thing we should do is test it on the second file, because we have the test file, which is families1, but the design document said to test it on the second set of code and comment the output down here. So output of, can I find that design? Okay. So yeah, let's find that second input file. Grab that off canvas. So let's go to our project file. Download the required thing. Throw it in here. Let's hope that this just works. Barry, birthday. R-A, R-I, C, C-A, C-H, C-L, C-O, C-R, D, D-U, D-Y, H-E, K-A, M-E-T-A-W-Z. Oh my gosh, this is actually working. My code actually works. This is amazing. Nice, it's almost 9 p.m. for me. Hey, Bill. Yeah, I tried to do a bit of an earlier stream this time around. Simply due to the fact, you know, reach a wider audience that way. Right now, we're not doing game dev specifically, but we are doing code, so I want to stick around and learn a couple things. Feel free to ask some questions. What's the font family CMD all about? So this is a program. Right, so this is a program I'm doing for class, and it's about structs in C, which is a pretty advanced topic, but essentially what we have to do is we're taking text from an input file that's basically randomly assorted, so we have their name, their sex, and their age, and we need to sort them into families. And once we sort them into families, we can search for their age. So right now, if my program's working correctly, Stan Marsh, if we search for age 9, should return Stan Marsh. So it did return him. Stan Marsh, Dylan Spuckler, Kenny McCormick, and Eric Cartman. So it seems to be working. I worked most of this out on another stream, and now we have to comment all this code and explain to my teacher how it all works, even though he knows exactly how it works, but he doesn't know exactly how it works, because like he wrote the project for us to do, but he didn't entirely for an online class, right? Well, it wasn't online initially, but due to this whole COVID situation, it's online now. So unfortunately, that's just the way it works. But yeah, the teacher I actually initially, this was a lecture we went to IRL, but times have changed. So let me go school. Year 2, semester 2. Just copy that prompt. And this was programming assignment number 6. What language is it coded in? This is C. This is C. It's one of the most... Well, it's not one of the most archaic languages. It's one of like the... It's a language that is still being used despite how it's lacking a lot of modern features. So it's like, this is pretty much like if you go to school for computer science, this is pretty much the hardest language you're probably gonna have to learn. And honestly, it's not that bad. It's just, it doesn't hold your hand, so to speak. But a lot of programming languages are basically built off of this language. So for instance, like Python, C++, Java, they all basically root back to this language. And that was the language I had to write this assignment in. Because this language compiles directly into assembly, which compiles directly into machine code. So basically, we're about 2 steps away from just being ones and zeros. Okay. So yeah, if you want to sit back and watch, maybe you could, I am commenting my code today, so this is actually a good opportunity to just like show, I guess you could like, as I'm commenting, I'll be explaining what all the code does. Right. I'll probably leave the intro comment for last. So this basically, this line is, because this is actually a C++ compiler. How much time did it took you, by the way? This specific assignment, I have the VOD privated, but I didn't spend all the time coding it in the VOD. So let's look. YouTube Studio, videos, or it should be live. So I spent about 4.5 hours on stream, and then coupled with that, so probably about 8 hours it took me to write this, and it's about 200 lines of code. So but it won't take you 8 hours to write 200 lines of code all the time. It's just because this project is like, we're dealing with structs, which are kind of like objects in C, and working with them is very difficult, and that's why this is like a 3rd year level course topic, right? So it's gonna be pretty hard. So, okay, so define CRT secure, no warnings. So this is, like, going back to what I was saying, this is a C++ compiler. So in order to run C code, you have to write this line at the front of your file for some reason. It's just something our teacher told us to do every time we write a C program. So if I take a look at my other programs in C, and I'm not going to pull those up, but all of them have this at the front. So adds, and I'm not going to comment that. So include studio.h, includes input output functions such as print and scanf. So basically, right now you will also add comments on your code. Yes, commenting your code is very important. That's something I wish I did more when I was developing my game. I mean, I'm the only person who ever reads my code for my game, so it doesn't matter too much. But if you expect anyone else to read your code, they should be able to tell just by reading comments. Pretty much, they should know what your code does. Well, it's very important to have good practices for documenting code. So includes input output functions such as printf and scanf. So basically, printf is a function you use to output to the console. So every time we run the code, right, all this had to be printed to the console, so that's what printf does. And scanf was how we were able to take information. fscanf is how we were able to take information from a file and have our program read it. And you'll have a function like these in every language, right? So Python, I'm pretty sure it's just print. In Java, it's system.out.print line. And are the names pre-chosen? I hope I said it correctly. Well, the names for these functions are pre-chosen. So like the language architects, when they were designing the language, they said, we're going to call our print function printf, and that actually stands for print formatted, because you can format your print statements, and similarly for fscanf. Okay, so what does this do? I actually forget why I added this. So let's break our code and see what it... Okay, so as we can see from the warnings, so this is, we included standard lib, includes dynamic allocating memory functions. Okay. What are the names on your assignment? Are they random names or are they pre-chosen by the professor? So as you can see, they're pre-chosen by a file that we download from the professor. And so this is just like, a lot of teachers will do this. They'll just like, so this is the Simpson family, right? In like the test file, if we run it on the test file, oh wait, no. We have Frank Zappa, right? So you basically, for the test file, did a bunch of musicians, I believe. You can actually get rid of this line. Sweet. So includes dynamic allocating memory functions. We'll get into that a bit later. That's a bit complicated, but basically it allows us to expand. We're in this assignment, we use a data structure called a linked list in order to store our families and the people inside those families. And in order to do that, we need to dynamically allocate memory. So like if we need to add a new person to that family, we need to be able to make that family the size of the data structure that contains that family. We need to extend that by one person. So every time we add to the data structure, we need to dynamically allocate memory so we can still store stuff in that data structure. Does C use tables, by the way, this program? It uses arrays, which are kind of like tables. I'm not sure. String.h includes string comparison functions, so we can determine the alphabetical order of family members. Because one thing you'll notice about this is these have to be sorted alphabetically. That was one of the requirements the teacher gave us. So struct person. Okay, so this is getting into what the assignment was mainly about. So these are structs, and basically how they were explained in the lecture. Well, it was a video. It was an IRL lecture, but is that structs are kind of like a very primitive version of objects. So in Java, and languages like C# and languages like Python, they use a paradigm called object-oriented programming, which provides a level of abstraction so that you don't necessarily need to know how everything works in the program or for you to do useful things with it. And a lot of programs are built around this structure, but C is very primitive in the fact that it has something called structs, which are kind of like objects, but they don't have all the same properties. So what we do is we create a struct person, a struct node, which contains a person, and then we add that person into a family, right? And this family is basically a linked list, which is a linked list, which you can think of as a list of people. So a family can be represented in data as just a list of people. By the way, you first learned C and then C#, or the opposite. I first learned C#. C# is much easier to learn than this, for sure. And by the way, C and C#, because like C# is pretty much completely maintained by Microsoft. Like, and C and C++, I think were created by completely different people. So I think C# is based off of C++ and C, but it's like so radically different and in so many ways that it's actually kind of weird that I think they called it C#, like, because a lot of it is just like Java. Like C# is closer to Java than it is to like C++ or C. It's kind of weird like that, but I don't know. C# is a cool language, so you don't have me complaining. Right, so a person struct we use to build nodes of people in a family linked list. And what does every person have? A person has a first name. Why does first name have 10 and last name has 12? Is it because this happened because of some large surname someone has? Honestly, that just has to do with the program design document. So in this design document my professor gave me, a family will consist of a last name string no more than 12 characters, and then a person will consist of a string no more than 10 characters. So my professor just basically said, in this project you're never going to be comparing anybody with a first name more than 10 characters, so you might as well just make it a set limit. In reality, if you were making this program for like actual use, you would want the data structure to be like 100, because you have no idea how long someone's name is going to be, right? So how should I describe this? The person's name. Oh, by the way, someone else. Oh, I see. Did you? Oh, the program did it. Oh, we had to type this out. So in most languages, the way you'll declare a string is you'll do string first name, right? But this is one of the primitive things about C. is it's very archaic in the fact that every string is just an array of characters, which is the definition of a string in a sense, right? But in C, you have to manually declare that it's an array of characters. There's no like string object or anything. Do you have to comment every line? See, here's the thing. In the real world, you wouldn't comment every line. But because this is an assignment, and my teacher is the type of person who really, really wants you to comment your code, I'm going to comment every line. In the real world, it might get actually kind of obnoxious if you comment every line. So, like, in the real world, you wouldn't comment this line. And you wouldn't comment a line here or here. But you would definitely comment the struct itself. But it's age. Person's sex. Alright. So a node that contains a person's data inside of a linked list. So going into linked lists a little bit, singly linked list. Basically, a linked list is just a list, and this is a singly linked list. So it's a data structure that has a head, it has a next node, right? So we have the node next to the node, and then and it contains some data, and it contains a pointer to the next data, and it's just that's how you create a list in a singly linked list. That's all there is to it. So the person struct or data, and we have a pointer to the next node in the list. Fairly simple data structure. Was it necessary to do a list? How about an alternative? So there are a couple of alternatives you could have done, one of which is an array list. Linked lists are good in this case. Actually, linked lists are actually kind of interesting because I don't know if they're used a lot in the real world, but they're a good data structure to learn, and you'll probably have to learn them at some point. You could have used an array list. Essentially anything that dynamically allocates memory, you could have potentially used. But in this case, it makes a lot of sense to use either array list or a linked list. But because of the way the assignment works, he specifically wants, does list use less RAM? Yeah, I think so. Because when you declare an array, say your name is like Patty, right? If you store this inside of an array, you're gonna take up 10, like this first name array takes up 10 space in memory, right? It takes up 10 characters worth of space in memory. But if you only have 4 characters to store, then you're wasting 6 characters worth of space. Now in this case, doesn't really matter that much, so we should just create an array, right? Doesn't matter a whole lot. It's like 7 characters worth of space. That's not a whole lot of bytes, right? So we're fine in this example. But if you're storing like thousands of elements, it might be better because the linked list only stores the amount of nodes in the list itself, right? So if we were to declare an array that stored each family member, then we might have potentially wasted space. But if we use the linked list, it's only taking up the same amount of memory that of the elements in the list itself, the amount of nodes. So struct family, the linked list of people that share a common last name. So the family name, the size of the linked list, a pointer to the head of the linked list. So going back, do we still have that picture? Yes, we do. So this is the head, right? So this head pointer doesn't contain any data, but it points to the head of the list. All right. This is a function that inserts data into a linked, inserts a person into a family linked list in alphabetical order. Actually, we can get rid of this as a, just put a function. A function that clears a linked list, a family linked list. All right, nice to see you back, Bill. All right, so I don't know what you saw while we were gone. I went over that this node front is the head pointer to the start of the list. That's all you pretty much need to know about that. And so I was starting to comment this function insert person. So in C, we have these things called function prototypes, which I don't really like a whole lot. Other languages don't have them. So it's basically you have to state what your function is, either in a header file or at the top of your file, like so, before you actually call it later. So we have a function insert person that inserts a person using a bunch of convoluted logic that I'll explain later into the linked list, right? But in order to call this in memory, we have to first define it up here before we even call it later. So we call it somewhere in main, right here and right here. But before we do that, we have to define it first as a prototype. Nerd. You're a nerd. There's someone from the YouTube chat. Alright. So anyway, do you have to declare something to call it in other newer languages? You have to declare variables. You don't have to make function prototypes though. Function prototypes aren't really a thing in newer languages, because it's like you're making redundant code essentially. Like if you think about what's actually happening, like if I make any changes to the function down here, I would then have to go back up here and change the parameters up here. So I have to edit like several things in order just to like make one change. And also I would have to edit it wherever it gets called too. So like I would have to make 2 changes at least if I want to change the parameters, and then if I call it anywhere, I would also have to change any places I would be calling it. So it's like it's just kind of annoying, to be honest. A function that clears a family linked list and a function that clears. Okay, so yeah, and sets its and frees its elements in memory. So when we're doing dynamic allocation in other languages, there's this thing called the garbage collector, that when you're no longer using elements that you've assigned values in memory, the garbage collector just takes care of it for you. That's one of the nice things about new languages. In C, however, you have to make sure you free each element of memory after you use it, or else you can run into what's called a memory leak, and that's bad. So you don't want to do that. So what we do is we call a function called destroy, and then we throw in our well, in this case, it's an array. We throw an array of linked lists, and then it destroys all of them systematically by freeing the language. So that's just a function we basically do because it's C. So find family. What does find family do again? Oh yes, so if the family linked list exists, this function returns an index to that linked list in a linked list array. So let me go ahead and explain what a linked list array is. This music's kind of loud for me. I'm gonna turn it down a little. Okay, so a linked list array is, what we're doing is we're storing so a family is a linked list. But what if you want to manage multiple families? Well, in that case, we could simply declare an array of families, and then we store our linked lists within that array. So this array essentially contains a bunch of pointers to the heads of linked lists. So we can manage we can systematically manage all the families. So what this function does is it basically, we take an array of families and then we search through it, and if we find a last name, an array contains a list in that case. Exactly. So if the family linked list exists, this function returns an index to that linked list in the linked list array, right? So yeah, I think you get that. We can move on. So basically it searches for that last name, and then if it finds that last name, we're good to go, basically. And if it doesn't find that family, it returns a value of -1. And -1 in programming is often returned if there's no value to be returned. If the family's not found, it returns a -1 instead of the index, because arrays don't have the negative indexes. So input function, this is where we basically get a first name, a last name, an age, a sex, and a file stream. So this is where we take an input file and we basically scan one line of that input file, and then we store it inside a person, inside a node. And then yeah, we store it inside of a person, I believe. Where is that function? It's a very small function. Input. Here we go. So yeah. So we're basically storing these values temporarily, and then we're going to create a person out of them later. Oh, so you take the character of that file and add it to the program. Yes. Yeah. So we're scanning the file line by line and basically taking in their sex, their age, and their first and last name, and we're using that information to organize the data. So input takes in value of a line and temporarily stores it in takes in person's information from an input file and stores it in local variables in main. So output family it does exactly what it says it does. So basically output family just prints the family to the console. So traverses through a family linked list and prints it out to the console. What if everything was scrambled but was in the correct order, like names, age, and sex? Would that take longer? Yeah, because you would have to if everything was scrambled, you would have to build in logic to figure out what is a character. you know, like, okay, if it's a single character, then it's probably the sex. If it's an int, then it's probably the age, and then like you would have to devise some sort of method to discern whether it's a first name or last name, and that's just not part of the assignment, so I'm not writing in that logic. And we're assuming the data is coming in organized. In the real world, though, depending on what you're working with, the data might not be organized, and that's where that sort of logic would come in. So, age search node. So, node front. What is age? It does. Age search. How do we call that? Is that what it's supposed to do? Okay. Traverses through a family linked list and prints out any traverses through families, any members of the family which match the given age. So in this function, we pass through an age, we pass through a last name, and we pass through a linked list, and then it'll traverse through the linked list by each member. And if we check that member and compare it to the current age that we input into the function, and if it matches that age, we print that person's name out onto the console. Receives an array of family linked lists and prints out the smallest sized and largest sized families. I think that's kind of self-explanatory. We're just searching through all the families and then just printing out which ones have the smallest members and the largest members in terms of like actual people. Main method. Index variable that is used in loops to traverse. Yeah, I think index variable that is used in loops is a good enough explanation. Local variable. So basically, in input we assign a bunch of values, and then we later insert these values into the linked list as a node. But in order to do that, we need to have some temporary variables that get passed around. So every time we input a new person, we change the value of age, sex, first name, and last name to equal the value that we need, essentially. local variable that stores currently being input person's age. So we're going to copy that. I'm going to paste it over here. First name. Est. And person's sex. So family index. So assigned used to, we use family index every time we find the, we input a person's data, and if their last name exists, we assign the returned value of find family to the family index. The index of the used to test the index of the person's family currently being input persons. In families. An array of family linked lists. So this is the actual variable we use to store the array of linked lists. So I don't know, how should I do this? Should I just make everything line up nice? When I turn it in, it's gonna look like garbage anyway. But I guess we could do this. Yeah, that works. So in order to get input from the file, we have to open a file stream that I've labeled input stream. And then, so we just open that, set it to the file name, and set it to read. So we're gonna read from the file. That's what that R stands for. A file stream that we use to input each person's data. Int n equals 0. The current amount of families in families. Input age equals 0. The age the user requests to search for. So when we run this, is family 10 because you know you will have 10 families. Family is 10 because, yeah, we'll have 10 or less families. So every time we print the families and then we are asked to search for an age, so this needs to be assigned to a value in code. So we use input age as a variable to store that. So enter an age to search for, 57. 57 gets assigned to input age, and then it searches for all people of age 57, and then it returns the correct amount. So a for loop that sets each element, each linked list in families to null. Actually, what's it? So he says in the design doc, in main, declare array struct, declare array statically, declare any variables. Initialize your array of family elements by setting each. Sets each family's size to 0. Sets each head node to null. So basically this just initializes every linked list to null at the beginning. Not entirely sure why he wants us to do that, but I guess it's so we don't get a null pointer exception later when we reference the size. Well, f e of f. So basically this is a while loop that takes in all the data and makes it into a linked list or an array of linked list. So while we are not at end of file, linked while loop that creates the entire array of family linked lists. Why do you have to set? Isn't like default 0? Yeah, I don't know. I would assume it would be 0. I mean, one thing we could do is we could have just done equals 0 up here, right? I don't know if we're allowed to do that. Maybe that's just a thing in C. You have to do that in C, but you don't have to do that anywhere else. Because I know in objects, by default, in objects in like a language like Java, you could set elements by default to like a value. But I guess you can't do that in C. While loop that creates an entire array of family linked lists from the input file. So at the end of this while loop, we've input in all the information we need, so we're going to close the file. And it's very important that you do this so you prevent errors. You have to make sure you close your files. So we have finished reading the data from the file, so we close the file. Okay, so first thing we do is once we enter our while loop and we want to read from the file and create a linked list, first thing we're going to have to do is get an information from a line. And we're going to keep doing that until we hit the end of the file. So every time we go through this loop, we're going to read one line from the file. Read data from a line in the file and assign its values to the local variables. Family index equals find family, last name, families, and n. So find out if the family exists in the array. If the family, so we call our find family function and pass through the last name, and they will return the index of the family if the family exists, else it will return -1. So if the family does not exist, that's essentially what this is saying, this if statement. If the family does not exist, if the family does exist, if it reads a file, why do you need to check if it exists? So there's two things that can happen. We read the file and we find a person, and if the person's family linked list already exists, then we can just add it to that linked list. If it doesn't exist, then we have to create a new linked list and add it to that, and we have to add it to we have to add it to the array, essentially. The file from their families will be created. So yeah, we either need to create a family when we find a person, or we need to add him or her to an existing family. So if the family does not exist, create a family with size 1 person. Oh, so you create a new family if it doesn't exist. Yeah, exactly. So assign the linked list at Alright, I'm back. Mom just had a question. Alright, so what we're gonna do is, yeah, we'll assign the linked list at n the last name. So if the family doesn't exist, we're gonna go to array at index n and assign the new last name to that index. And then down here, we're going to want to make sure we increment n so we don't overwrite our family in the future. So this essentially means n plus 1. N equals n plus 1. But it's easier to just write plus plus. Increment n, so we do not overwrite our family. When we add another family. Okay, so add person to our new linked list. That's what insert person does. And I'll go insert, yeah. So insert person is, yeah, that's what we do. We'll cover that later. Family index. Oh yeah. So again, using family index. So if the family does exist, then we know we have our information. All that we need is in family index. Insert a person at his, hers, family linked list. Increase the recorded size of the family by 1. So yeah, we're doing size plus plus, which is essentially the same thing we're doing up here, but we're just initializing it to 1. Okay, so that's all our logic, essentially, for taking in a new person, at least in our main method. So signals, this is just our first line of code that we actually print, which just signals to the user that we are printing the elements all of the linked lists in families. What does families.front contain? That contains the head of the linked list, so that's like the start. Yeah, a lot of the times they call it head. For some reason, my teacher for this assignment called it front. To each his own. It has the same purpose. So yeah, families index front. So this is a loop that just prints out all the families. Print family's name. Right. Output the members of the family. That's essentially all it does. So we run our code, family's name, and then just the family itself. Prompts the user to search for an age takes in the age the user input and assigns it to input age. If the user does not enter 0, then we continue to make searches for the age. So basically, if we enter 57, it returns us people with 57, and then if we do 42, it returns us with people who are age 42, which is no one. And then we need somehow to break out of this loop. So in this assignment, he just says if they enter 0, break out of the loop, and then we print the largest and smallest families. Prompts the user that we are searching for the age. Loop that searches for the age in all families. Searches through the age of all families. Pretty simple. Does it contain the name of the first name ever being on that family, which is outputted like Simpson's family? Does it contain his name inside here as well? So are you talking about families.front? So families.front is a pointer to a node. Or no, because it is already being outputted before on name family. So families.front is a node, essentially. And a node contains a person. And that person contains a first name, an age, and a sex. And it also contains a pointer to the next node in the list. So it contains a first name. Only the family struct, or like the linked list itself, contains the last name. So like, once we input the last name once, that information continuously gets discarded because we don't need to store the last name twice. That's a waste of space. Does it contain the front inside the families? The array of families contains the front nodes. So like, do we have paint? So we have an array, and then we have a node, right? Let's call this node 1, right? And this node points to another node, which points to another node. And then we have another node, say let's call this 2. So we have nodes Howie and Zappa. This points to another node, points to another node. So this node is a person. So this does contain a first name as well. But it also contains a pointer to the next node. Oh, so it's like 2 and then the nodes. Yeah, so you can think of a node as containing everything that I'm drawing this rectangle around. So we have the node itself, and then we have a pointer to the next node. And that's how you kind of keep track of these data structures. Is because all you need is the node to have a pointer to the next node in the list, and then you can keep track of yeah. So because like these nodes, they don't need to know what's over here, right? They don't need to know what node let's say like node 2012, what node 22 is doing. They just need to know where node 21 is. So we just like nodes are very these, especially in a singly list, these nodes are very dumb. They do not need to know the locations of much stuff. So okay, so at the end of our search, we prompt the user to search for another age if the user, actually we can just comment, we can just okay, that's all we need. Wait a second. Oh, there we are. It hid that, it was hiding this, thing right there for a second. Okay. So we've commented all the logic in our program thus far, except when we hit the end, we have one more thing to do, which is print out the largest and smallest families. And we've taken that entire process where you output the largest and smallest families, and we've prints the largest and smallest sized families, deallocates the memory of the linked lists. And system.pos is basically all that does is system.pos, all it does is pause the program and then prompt this, press any key to continue. So that's really nice, because if we took out system.pos, if we got to the end of the program, so let's just take that out for a second. If we got to the end of the program, we wouldn't be able to see this output, the output of smallest, largest families, because the program automatically terminates after it's over. So we need to add a pause at the end, which we did. Adds a pause so we can copy our output. End of program. Sick. So all the logic of our program is in the first 100 lines of code. Now we just need to explain the methods. The methods of the code. The methods of our madness. So what we can do is I'm going to just copy this comment and paste it. Clears a family linked list array and frees its elements in memory. So we have, actually I'll just, that is used to loop through the elements of the linked list. Okay, so the way this function works, this destroy function, is this is called at the end of the program when we want to deallocate the memory from our linked list so we don't get memory leaks. And the way we do this is we have two loops. We have an outer loop and we have an inner loop. So our outer loop loops through all families in families so that's our array of linked lists, and then loops through all nodes of a family and frees them from memory. So basically this outer loop traverses to one spot, and then our inner loop goes down and then frees each element from the array. And then our outer loop moves on, then we have our inner loop run this process again, deallocating everything, and then it just keeps going until it hits the end of n elements, right? And the way we do that is we perform a swap. So this is kind of complicated. So a temp node that acts as the node we just free. So basically the way we do this is we traverse it like one at a time. So we start at the front, assign front current front to temp, change front's location to the next node, deallocate temp or the previous node. Actually, it might make more sense to make this prev. So prev is the current node, then we make the current node the next node, and then we free prev. So prev stands for previous. Set the linked list size to 0. Set the family name to or empty. Let's just do an empty string. So we're just resetting and destroying everything we made. Great. All right. So yeah, that's it. That function pretty much explained. All right, this one's kind of scary, but we can do it. Alright, so the first thing we do when we're inserting person into the linked list is we allocate a new node to a person. Pointer node to current node in traversal. I'll explain what this is later. Pointer to previous node in traversal. So what we do here is copy the new data to our new nodes. Oh wait, yeah. To our new node. Set first name. Set the age. Set the sex. Cool. So we're just setting our new node to have all this data. So we're making a person that we're adding to our list essentially. So this is okay, we have a couple different cases when we're adding a node to a list. And it gets kind of complicated, so I'm going to try to explain the best I can. But in this case, add a node to an empty list. So if our head of our list is null, that means our list is empty. Set the head. Actually, you know what? I want this to be a little indented. Add a node to an empty list. Set the head to the new node. The next element of our list is null. So essentially, going back into Paint. Crap. So we're creating a list, and if the list is empty, then we're just going to want to make a pointer, or we're going to want to make a node, and we're going to set that node to the head because there's nothing else to, right? And then we're going to set that pointer to nothing. That's all we're doing here. So that one's fairly simple. So our other case is if our new node name is alphabetically in front of the head. Right? So in this case, we're comparing the front first name to our current first name that we're trying to add. If the list is empty, then why should we do this if it's already non-existent? Oh, are you talking about setting front next to null? Because if we don't set front next to null, actually, what does happen? Yeah, so we get an exception down here when we're trying to add nodes later if we don't set it to null now. Because what we're setting it to, if it's not set to null, it gets set to like unallocated memory, which is a bit different than null, I think. And we run into trouble later if we don't set this to null. So there you go. That's the reasoning. Honestly, this function was probably the hardest part of the assignment. Just figuring out linked list in C. But we out here, we're programming, we're gaming. So, yeah, so we're comparing these two strings, and if the result is less than 0, aka our first name is, like, say, like, our first name is Alan, and this person's name that is the current head of the list is Barry, right? So we have Barry, and he's the front of the list, but we actually want to add Alan in. So what we want to do is we basically want to move Barry over, right? And then insert Alan in his place. So that's this case. So set the head to be the front node. Set the front to the new node. So we move the front, yeah. We basically just move everything over one spot. But because it's a linked list, we don't have, like, basically Barry didn't really move, but just like the position of front moved, if that makes any sense. So like, really the pointer to front just moved to here, and we set this, and we created this new arrow to point to Barry. So it's actually kind of clever, because if you had an array and you added to the front, say you wanted to add -1 and you wanted it to be in order, you would have to move every element over manually, because arrays do not have pointers. So that's a lot of work. Yeah, because the front is static, right? Yeah, because arrays are statically allocated, but linked lists are dynamically allocated, so you get a bit more freedom. Okay. So this moves to our else. If we are adding to the middle or the end of the list. So our first two cases were if we're adding to the front. In these last two cases, we're adding to the back. Okay, so that didn't change anything. That's good. All right. So this is where our current and previous nodes come in. Set current to front. And basically, we want to traverse the list using our current node, but we don't want to actually, and we want to set that to the front. So we're going to be traversing through each node of the list and comparing it to our new node. And if our new node is alphabetically in front of the next node, then we want to squeeze it in, basically, if that makes any sense. So if, like, say we have somebody with the name AC, right? We want them to be in the middle between A and B, right? So we're going to traverse through the list using current, and we're going to compare current to AC. And once we get to B, current will be AC will be alphabetically superior in a way to B. So we're going to, our code is just going to squeeze in AC here. Okay. So prev equals current. Yeah, and prev will be current. So in order to do this, we're going to have to make a previous node too, so we can reference A, because A also needs to point to AC. So this will be prev eventually. This will be current. And this will be our new node, right? PS node that references the node just in front of the alphabetically inferior node. Let's put around quotes around that, because that kind of sounds weird. Wow. Our current node is alphabetically inferior to the current node, and we have not reached the end of the list. So there's two cases that can happen here, right? So we can either insert in the middle, or we could just keep traversing until we hit the end of the list, which is what this check is for. Because over here, this is going to be null, right? So that might be a case too. So update prev to the current node. Yeah, update prev. Update update current to the next node. So we're going to keep doing that until one of these conditions is false. If we are in the middle of the list, we're going to break out of the while loop. If we're in the middle of this, we're going to break out of the while loop once this condition goes from greater to 0 to less than 0. So our code, if it's less than 0, point our new node to the alphabetically inferior node. Point the alphabetically superior node to the new node. All right, so if we reach if we are adding to the end of the list, if we add to the end of the list, then we're going to point to nothing. So our new node point to have new node point to nothing, have the current node point to new node. So the current node at that point would be B, so it's going to point to us, and we're going to point to nothing because we're at the end of the list. Return a pointer to the new node. And the reason we return something out of this function, I'm not really sure why we do that because we never do anything with this information, but hey, the teacher told me to do that, so. Okay. So if you understood that, you're probably going to understand the rest of this, because the rest of this is pretty easy compared to that. We're almost there. If the family linked list exists, this function returns an index to that linked list in a linked list array. Indexes of families. Yeah, so we're gonna have I, we're gonna loop that traverses with a number of families. If the last name is equal to the current family's last name. Then we return the index of that family. Else family was not found. So we return -1. Maybe we should do family does not exist yet. Cool. Use scanf scanf to input and store information from a line in the file. If I is less than n, you add the n because you don't know how many times this will be executed again. If I is less than n. If I is less than n, then you add I, because we know we're going to loop. So with the for loops, usually you use for loops when you know exactly how many times you're going to be iterating, or you have an idea of exactly how many times you're going to be iterating. So basically, we're start at 0 because it's the first index of the array. And as long as I is less than that section of the array we're iterating through, we're going to increase I. So if we don't find it in the first index, then we increase the index, and then we search the second, then the third, then the fourth, and the fifth, and then that's up until we get n traversals. And then once we get n traversals, we know it's not in the array, so we return -1. So basically what this is saying is like start at 0, traverse n times, because we're incrementing by 1 each time. So the first time we traverse through the way I equals 0. Now at the end of that traversal, we set I equal to 1, and then I equal to 2, and then I equal to 3, and then eventually we get to a point where I is more than or equal to n, and then we break out of the loop. And then if we have to break out of the loop, if I equals more than n, then we would be returning -1 because the family does not exist. If, however, the family does exist, then after this if statement, we will return I, and this return I statement breaks out of the loop and the function. So anytime you see return, that basically means do this, return this value, and end the function. So this breaks out of the loop. So we just keep searching until we find, yeah. So basically, if we find the last name we're looking for, we end the function. And if we don't find the last name we're looking for, we also end the function. Those are the two exit conditions they're called. Alright, so we have output family. Pointer to actually let's change temp to current. So set our current to the front of the list while we have not hit the end of the list. Print the first name. Of our current node. And then we move current to the next node in the list. What does the %s, %c, %d mean? These are the values from the text file. Yeah. So basically, %s is a string, %s is a string, %c is a character, and %d is an integer. So we assign %s to first name, we assign %s to last name, we assign %c to our sex, and we assign %d to our age. That's all that does. And this is the input stream, which is our file, basically. What's the difference between S and C? S is an array of characters, and C is a singular character. So A would be a character, ABC would be a string, or just AB would be a string, because it's more than one character. And a string, if you think about it, and this is the way it's implemented in C, is actually an array of characters. Whereas a single character, a single character is just one element. Yeah. So these are all characters. That's the difference. Alright, we're almost done. We're almost there. I mean, we still have a huge ass intro comment that we're gonna have to type up. It's gonna be a pain in the ass. But alright. Let's go. So this age search function actually is very similar to the output family function. If it's like John 13, you do %s plus %d. I'm not sure. I think the way that would actually compile is John 13 would just get returned as a string. So if you want to add integers, you would have to put a space between John and 13. Does that make sense? Because Oh yeah, and that same logic applies to the print statements too. So like right here, we're printing out the first name. That's the only way. Yeah, I believe so. I mean, actually, you know what? No, I'm wrong. I'm wrong. There's other ways. There's this thing called regex that's a bit more complex that you can use. I don't know if you can do that in C, but there is a thing called regex you can use to get more complex like input. I don't think you can use that using scanf though. I think there's a whole lot you can learn about regex though. But yeah, if current age equals our input equals the age the user is searching for, output the name of our current node. Actually, that's fine. I'm fine with that. Now, here's the kind of like cool thing about this. Is you notice how like this is like the really cool part about programming that I like, at least, is that you're able to break down all these problems into like smaller solvable problems. So like you have a destroy function, you have an insert person function, you have a find family function, like all these different functions to do different things. And that's kind of like what good programming is about, is like breaking your problems down into smaller problems so you don't have to do more work. And also it's good to do it this way because not only do you have to do less work, but the work you do is applicable to different situations. The index in families of our smallest family. The index in families of our largest family. So basically this just loops through the entire list. Loops through all families in families and assigns the smallest and largest family index. If our current family is larger than the supposed largest family, update the largest family index to be the current index. So does that make any sense? I hope this like logic makes sense. Basically, you're just comparing the size, and then you update the size accordingly. Just basically find the smallest families. Output the largest family out to the console call output family. So we're using a function we defined earlier to make our life a bit easier now. Why is it if instead of else? I guess you could get away with else. Well, you could get away with else if. But you couldn't get away with else. Because just because something isn't the largest family doesn't mean it's the smallest. It might be in between. Right? So we could get away with an else if. So yeah, it outputs the same result, but you couldn't get away with an else because it could be in between. Oh, because if it isn't greater than, it could be less than or equal to. Yeah. Yeah. Yeah, so all right. You have to run some tests real quick. And we have to record the output of these tests. All right. looks like it's doing it alphabetically. Looks like we have a successful program here. Now, just to make sure we got this right, let's check against the GG. Yeah. Let's check against these names. So we have Homer's 39. Who else is 39? Loughton. Yep, got him. Okay. Who else is 42? We got Gerald. We have anyone else that is 42? Nope. Okay, cool. Is anyone 61? Nope. Okay. 10. So we have a couple people who are 10. It's just, yeah. Millhouse. Oh, there he is. Rod. Yep. Terry. Yep. Sherry. Yep. Kyle. Yep. Heather. Yep. Whitney. Yep. Did we get Bart? Yeah, okay. So I think, yeah, that was right. And then 8. 8's just 2 people. So Todd. And Dubia. Oh wait, it's 3 people. Lisa. Control F and search 10. Yeah, I forgot about that. I forgot they have Control F in Notepad. Oh wait, Cartman. We want to search for Cart. So there's only 2 people with Cartman. And then there's how many people? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. And that's Buckler. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, I might have missed one. One, 2, 3, 4, 5, 6, 7, 8. I think we're fine. I think we're good. Just to give you an example, this is like the example output he gave. So we 39, 42, 61, 10, 16, and 8. Submit your commented code in the output running program on the 2nd. Okay. Yeah, so we did that. So now that the code's commented, we have to write this lengthy explanation of what it does. This is a program that... You know what? I'm gonna go grab a water real quick. I'll be right back. Duck, duck, go, fella. Yeah, duck, duck, go for the win. Alright. I'm back. So, got some seltzer. Yeah, dude. Not only are we DuckDuckGo gang, but we're running the Brave browser. Because privacy for the win. Chromium without the fluff. Ugh. So this is a program. Linux is the next goal. Okay, so this computer, believe it or not, this computer dual boots Pop! OS. Right. So I've played around with Linux a little bit. Problem is, if you want to use Visual Studio, which I have to for class, Pop! OS, that's my distribution. Have you heard of that one? It's like a fork of Ubuntu that's maintained by like these system manufacturers called System 76, and it's like optimized out of the box for like gaming and productivity stuff. Alright, this is a program that creates and outputs data from an array of linked lists called families. Each family is a linked list struct that each family is a linked list struct that contains nodes of struct of node which contain data of structs of people. See comments for info, lol, just that. Dude. The amount of commenting, like, I think, how long have I been streaming? I've been streaming for 2 hours. I haven't even done any actual coding. I've just been commenting. That's how much I care about, like, just fucking getting a good grade on these assignments, dude. It's, yeah, I don't know, like, how you could, I don't know. It's crazy. The program takes in input from a text file using a file stream and an input function. This data is used to create a new linked list or add a node to a currently existing linked list family in families. Once our array of struct families has been filled with our data, we then output this data to the user using a loop and our output family function. Comments is like 20% of the time spent on this project at least. Yeah, honestly, you're probably right. It's hopefully worth it though. Like, I mean, it's what you got to do to get a good grade, pretty much. I mean, other professors. Maybe after I'm done here, I'll show you some projects I got from other professors. I did not comment nearly as much, but they're just like totally fine with that. Like, this is like overkill, but for this teacher, trust me, like, if you don't do overkill, he'll find something to take off points for. Like, this, let me show you another project I did for this teacher. Year 2, semester 2, 362. I think this one's graded. Okay, so this is like a tortoise and the hare program, and we were supposed to basically do a bunch of like traversal with the tortoise and the hare and all this stuff. You can see I comment like quite a bit, right? Like, I mean, I'm not commenting every line, but it's like still quite a bit, and like the program works flawlessly. And like I think I got like a 91. I mean, it's just like, what? I guess I think his main problem was I just didn't put enough of a, like, he didn't like this intro comment really, despite it being really large. This one, these next two assignments, this is my entire intro comment. So hopefully he grades those nicely. I'm like 3 assignments ahead of where I need to be, which is actually kind of epic. But once our array of struct has been filled with our data, we then output this data to the user using a loop and our output family function. Okay, what do we do after that? We then prompt the user to enter an age to search. We then loop through our families. All our families, and then use age search to output members of each family that have the same age as the input age. We then, the program concludes, oh yeah, we gotta add the user enters 0 to stop searching for ages. The program ends with the output of our families. Program ends with the output of our families of our largest and smallest families. Smallest sized families. With the output of our largest and smallest sized families. We use a pre function output families to what's the function called? Smallest, largest. To do this. Alright. This is a program that creates and outputs data from an array of linked lists called families. Each family is a linked list struct that contains structs of nodes which contains data of structs of people. The program takes an input from a text file using file stream and an input function. This data is used to either create a new linked list or add a node to a currently existing linked list family and families. Once our array of struct family has been filled with our data, we then output this data to the user using a loop in our output family function. We then prompt the user to enter an age for the search for. We then loop through all our families and then use age search to output members of each family that have the same age as input age. As the input age, the user enters 0 to stop searching for ages. The program ends with the output of our largest and smallest size families. We use the function smallest largest to do this. We then deallocate if I don't talk about the deallocation of these nodes, he's gonna find a way to take out points for that, I swear. Deallocate the nodes, the linked lists in families using deallocate memory from the linked list and families using the destroy function. Okay, I covered insert person, right? Family and families. Okay, gotcha. Insert person, destroy, find family. Actually, we might not be done. We determine whether or not to create or add to a family by the result of find family. You mentioned output family, you mentioned, did we mention age search? Something random. Are you trying, by the way, to get that Valorant drop by watching streamers? Nah. Like, Valorant, okay. It looks like a really fun, kind of like, oh, I wouldn't say it's really fun. It looks like CSGO with some, like, abilities here and there. I'm not really that interested in playing Valorant, I'm gonna be honest. Like, I'm not really that much of a multiplayer gamer. Like, I just don't... I'm not that competitive. It's Overwatch, but CSGO, lol. Yeah, but it's like, I don't feel like it's that good at being like an Overwatch. Like, I don't know. I haven't watched a lot of it, but it just doesn't seem that good at being Overwatch. And it looks like it's okay at being CSGO. And also, if you're watching streamers just to get drops, I'm just like maybe spend your time somewhere else. I don't know. Like, Let's do. I think we're done. I know someone who watched 20 hours of streams to get that drop, but nah. I'm not, because I don't have my PC yet, and when I do, the game will be out. So are people trying to get these drops? Are people trying to get these drops because it gives them access to the closed beta? Because, dude, like, I do not care enough. Like, I do not care enough at all about like, I don't know. Like the thing is like whenever a new game comes out, even if I'm hyped for it, I'm just like, all right, epic, new game out that I'm gonna play. I'm gonna wait still like 6 months to buy it though. Like I don't know, maybe I'm just a cheap ass, but like that's just my attitude towards like tons of stuff. Like I already have so many games in my Steam library. Like, well, I only have 2 that I haven't played, but like that's still like quite a few games. Like I still need to play Prey, I still need to play Transpose. I have like a couple games on the Twitch launcher that I need to play still that I got for free. But yeah. Alright, so now just make sure we just save this. Open up the project file. Open with Notepad just to make sure. Okay. Looks like everything's there. And we'll save this to Google Drive. Because I do not trust Windows to not like break during an update. Am I right? Save everything to Google Drive. By the way, I wish they could make programs Linux friendly as well. All the tech. Do you use Zoom too? I use Zoom for work sometimes. We just had like a family Easter meeting the other day on Zoom. Apparently Zoom's like super insecure though. Epic. Here's the victory lap. I get to close out of all my programs. GG. Yeah. Alright. Well, Bill, you have me on Discord, so if you want to message me, feel free to reach out. But I think I'm going to stop the stream. Thank you, Windows Defender. Yeah, I will be streaming game dev tomorrow. More than likely. So I'll be doing some game dev stuff. And who knows what the rest of the week will entail, but I will definitely be trying to stream tomorrow. So catch me, I guess, around 12 p.m. Eastern is what I try to shoot for. So, yeah. Have a good one.